how certain new product development teams go into a successful innovative product, and how certain new product development teams don't go into an innovative product. And you see where it changes. You can't anticipate it, but you visualize where it goes. Now that's agent-based simulation. I'll give you a few examples of projects that we've done with that, right? So individuals have limited characteristics, 4, 5, 6 characteristics maximum. Each individual optimizes his or her goal, whatever goal that might be, highest profit, most fun, I mean, you define a goal, it doesn't matter, and a limited number of interaction rules, right? How do we interact, when do we interact? Now, if you go to the broader area of artificial intelligence and complexity, we've spoken about agent-based simulations, right? That is one very successful thing. Another technique is artificial neural networks, right? And what you do in artificial neural networks is that you try to simulate the brain operation. And as I've said somewhere, the brain is a few billions of neurons that interact with each other. Heat, it yes or no goes over a threshold value. If it goes over a threshold value, it shoots to the neighbor, period, and that's it. And that continuous heating and shooting and heating and shooting makes intelligence. Now, you have software simulations that actually don't do exactly the same, but that try to simulate that kind of behavior, and where you can train like a loan officer. So you train the system just like you train a human. How do you train a loan officer? By giving him 20 examples. Okay, these are 20 files, now learn it by heart, do whatever, but that's what you'll have to do. With an artificial neural network, you do exactly the same. You train the system with 20, 30, 100 cases until it learns how to take a decision. Right? It's a very powerful thing. The next technique is genetic algorithms. That is based on genetic manipulation of strings. So, if you, a good example of genetic algorithms is the recognition of criminals, right? So, if you ask somebody who has been a victim of a criminal act to give a robot picture, it's very difficult, since of course the person has seen the criminal, but it is so much emotional that you can't express that anymore. So a technique that has been developed is showing, say, 20 pictures. Ask the victim which are the 2 closest, keep the 2, and genetically manipulate the 18 others. So you pull off a nose, you put off another nose, you pull off an ear, you put on another. Just like that, at random. You represent the 20 pictures and you again ask which are the 2 closest. These 2. You manipulate the 18 next one. You do that a number of times, and in 4, 5, 6 iterations, you get to an almost 85-90% hit. Now, be careful not to continue too far, since you make it a self-fulfilling prophecy. Of course, if I can show you enough pictures, you're going to say yes at the end. But in 4, 5, 6 iterations, you get through that. Now, you can do genetic algorithms are used for the traveling salesman problem, are used for portfolio management, and there's a lot of use of genetic algorithms. Fuzzy logic is the concept of what we have in classical 0-1 logic is you're either large or you're small. You're tall or you're small, and that suddenly changes. That's of course not true. They say, well, okay, we make 3 categories. We have the small one, the medium ones, and the tall ones. Yeah. So the tall ones start at 180. That means that you're medium if you're 179, and tall that when you're 181. Yeah, I mean, and you can make many groups. Fuzzy logic takes it completely different and say you're always member of everything, but to a different degree. I am to a higher degree member of the tall people than that I'm member of the small people. I'm also a member of the small people, but to a very little degree. You see? And at the same time, you have memberships. So you're member of different clubs at the same time, which allows you to give overlapping rules, and which allows you to get smooth behavior. And the most famous application of fuzzy logic is a fuzzy air conditioner, which you have almost everywhere now, where you have 2 buttons, more or less, and that's it. Right? And according to what you feel, you want it warmer or colder, you push and it smoothly goes up. Right? It's not like previously where you have an air conditioner that switches on, makes a hell of a noise until it cools down 3 degrees, switches off, so you're again awake in your hotel room, right? And then half an hour later, it switches on again. So it's on, off. That's control theory. Fuzzy logic is smoothly. If it becomes warmer, it turns a little bit harder. If it becomes cooler, it turns a little bit less, right? And then, of course, the last one is a combination of neural networks, the concept of learning with the concept of fuzziness. So where you have fuzzy concepts that can learn, that I personally think is really the future. Right, so, okay. So as I said, I'll give you a few examples of projects that we run either with agents or neural networks. You can't do everything, so it's an arbitrary choice. The difference between agents and neural networks give you an emergent structure. They don't allow you to work with different agents. So they don't allow you to identify a sales manager and a production manager and a marketing manager. They can just see how out of different elements behavior emerges. Now, for certain applications that's perfect. For certain applications you might have an interest to be able to point to different agents. I have 2 marketing managers, 3 salespeople, etc. Then you have to go to agent-based simulations. Second advantage of agent-based simulations, it gives you communication rules. Neural networks doesn't give you communication rules, it just simulates you the communication, the behavior. Doesn't give you the rules, right? That are the 2 main differences. Good. A few examples. I just mentioned already the project where we used agent-based simulations in order to simulate the success or failure of innovation projects, which was in cooperation with Sara Lee. And the nice thing was, using agents, we were able to visualize when and where an innovation went wrong, right? And of course we have been able to draw a few general conclusions about how to deal with innovation, right? It's one project. Another one was innovation in small and medium enterprises. There's a big idea that government can help to sponsor, to fund innovation with small and medium enterprises, but in order to be able to do that, you have to know that you have an impact on the variables that play a role in there. So we did an analysis using neural networks and focus groups in order to see what makes innovation work out in an SME. And at the end of the day, you find out that all the elements that work out is very much a dynamic process and not that much externalities that change the behavior of the entrepreneur. So in other words, government can't do a lot to stimulate innovation in SME, so you can as well stop dumping money in things that don't work. A very interesting project we've done was the use of agents in order to simulate the telemedicine market. And that was for a company in order to decide about its strategy, its introduction strategy, how would we do that. So that was quite interesting. We've used neural networks in knowledge management at AkzoNobel. AkzoNobel is a large multinational petrochemical company. And in order to identify how to improve the knowledge creating capability of people. Right? So again, if we consider that knowledge is not something, it's not information, it is not something simple that you can transfer, but that knowledge is created in the interaction of people, how then can you transfer knowledge, and how can you make sure that people learn, acquire more knowledge. We've done an interesting simulation on what I call information ecology. Today we have loads of information. People don't know anymore where to look first. Can you find another way of exchanging information between people that take decisions, so to limit the volume of information, but nevertheless get the necessary information to take a good decision? And